Let's consider a very common question about charges and the electric field. It is given two charges and question is where can the electric field be zero? What should you know about the electric field strength? It is denoted by E and its magnitude is equal to some constant multiplied by charge and divided by distance squared. So it's directly proportional to charge and inversely proportional to distance squared, and it's vector quantity and is directed from plus to minus. And if there are two or more vectors, the resultant vector should be found as the sum of vectors. So let's consider position 2. The electric field strength produced by charge plus 10 is directed from plus to minus, so it's directed from plus, so it's directed to the right. It's vector which is directed to the right. Field produced by -5, direction is from plus to minus, so produced by minus, it is directed to minus, so it's also to the right. And we can see there are two vectors which are directed to the right, hence the resultant vector is also to the right, and we cannot get zero at all. And it's not necessary to consider magnitudes. Let's consider position 1. Field produced by plus 10, direction is from plus, so it's to the left. Field produced by plus 10 is to the left. And field produced by -5 is to the right. Since they are in different directions, let's consider magnitudes. Magnitude produced by plus 10, we can see that it has, it means charge plus 10. It has the greater charge, so numerator is greater, but it has the smaller distance, so denominator is also smaller, but it's always smaller, and numerator definitely it's always larger. So at any position to the left from plus 10, we will get that field produced by plus 10 will be always larger, because Q numerator is always larger and distance is always smaller. Hence the resultant vector, the resultant electric field strength vector is to the left, and we cannot get zero at all. And let's consider position 3. Field produced by plus 10 is directed to the right, and field produced by -5 to minus, so it is directed to the left. And since they are in opposite directions, let's consider magnitudes. Magnitude produced by -5, we can see that it has the smaller charge, but also it has the smaller distance. The smaller numerator decreases the result, but the smaller denominator increases the result. And for 10, we can see field magnitude of the field produced by plus 10. It has the greater charge, so it has the greater numerator, and it has also the greater denominator, because distance is also greater. Hence it may be situation something like that 5/20 is 1/4, and we can get that magnitudes are equal, and since they are in opposite directions, these two vectors are in opposite directions, we can get field to be equal to 0. So the correct answer is 3. It's C, position 3 only. And that's all for this question.